I'd have to say the defining moment in my scientific career was the work that we did in discovering the male sex-determining gene and proving that it was the correct gene. And it was a very exciting period in my scientific career because it was a race against another lab. We were both trying to find the same gene. There was going to be a winner and a loser, and fortunately we were the winners.
Peter has made his name even at his formative phase of his career as a postdoctoral scientist in London. He co-discovered the gene that controls how the boys become boys.
This is the sort of discovery and the sort of scientific moment that everybody dreams about in their scientific career, and I was so lucky that it happened to me. It completely changed the course of my career and my research.
I think the significance of finding out what it was that made you a male rather than a female was really astounding, and it's probably one of the most cited pieces of basic biology in modern history.
Certain genetic steps have to happen to make the body male or female, and these steps occur during embryonic development. Certain other genetic steps have to happen to instruct the germ cells to become sperm or eggs. So the discoveries that we made recently are about finding the genetic instructions, the molecular instructions that tell germ cells which way to go.
It all comes down to a very simple molecule that you can actually engineer and manipulate in a culture system outside the embryo, in other words, and change the fate of the cell. And this is a major shift in the paradigm, and that has a major impact in the field.
In a broader context, understanding the genetic instructions that go on in the embryo will be very applicable to stem cell research, where one is trying to program cells to make tissues of a particular type.
One of the potential applications of Peter's work on the switch of cell fate during the germ cell development is that it may have some implication of controlling how sex development occurs. And through these, we can understand why abnormal sex development may happen.
As a biomedical researcher, it's very important to us to have the feeling that the work that we do is going to help somebody at the end of the day. And in our society, a lot of children are born with indeterminate gender or sex reversal, and when this happens, it's really a medical crisis for those families, and somehow they have to work out how to deal with it. So the research that we do helps these families come to grips with what's happened, and it also helps surgeons make more informed decisions about how to deal with these children medically.
The impact of this research on society in general is a growing understanding of what determines whether you're fertile or not fertile, whether you can reproduce or not reproduce. And of course to humans that's really key.
Now that we've discovered the molecular signals, it might be possible in future to harness those instructions in stem cell research, for example to try to make eggs or sperm in a dish, which would obviously present tremendous advantages in terms of fertility and infertility management.
In that context, which is really basic biology, Koops has gone further and said understanding the difference between male and female and understanding how reproduction works can be targeted towards controlling pest species, and I think that's really a fantastic leap forward.
Not only is this research useful in a medical context, but I got to thinking maybe understanding sexual development could be useful for pest control. So the project that we're doing with cane toads is all about trying to skew sex ratios in cane toads. It's a genetic manipulation strategy. So again, if this works, it will be very exciting because it will be a very positive outcome of genetic research and genetic manipulation.
Well, the first time I met Peter was that occasion that I invited him to give a seminar at my institute. I sort of expected someone come to give the talk, well-dressed and have a tie on. He greatly surprised me by turning up in t-shirts and shorts and a pair of different socks. It was a great shock for a seminar speaker to turn up like that, and that was a really indelible experience.
You know, there's this clash between Peter, the really neat and pedantic, and Peter, the person who never wears matched socks, and I think it's actually deliberately cultivated.
He's very deliberate in the way he dressed. That is extremely organized to make it look casual.
People do describe me as a tidy person, and I suppose as a geneticist and of Dutch background, I would be hard-pressed to deny a predilection for a certain amount of order and tidiness.
He walked along the lab and pass a student's bench and suddenly trace back and realign every single instrument on the bench. He just can't stand things not in order.
There's lots of really unique things about Koops. There's not too many people that would probably prefer to come to work in his pyjamas, rides his bike religiously every day. There's not too many researchers I know that take their sabbatical in the Italian Alps and completely shut themselves off from the rest of the world and read lots of books on interpersonal relationships. He's really quite a unique person. He takes a different approach to the approaches of many.
Quite often I'll work away on a crazy idea and see if it'll work first before revealing that that's what I'm working on, by which time I already know that this is going to be a useful way to go.
He's also a very good communicator, and that helps a lot because he showed me sometimes the letter he has written to the editor of a journal and pleading his case that my paper is the best in the world. Take it.
If you were to ask my team how they would describe me, they would probably say busy, busy and busy.
If I had to describe Koops in 3 words:
left of centre,
relentless,
very focused,
odd.
He wears bike pants in the lab sometimes and odd coloured socks.
This is the problem. If you ride your bike to work, occasionally you have those horror moments when you reach the locker room and realise that you failed to pack your work clothes, so you have to spend your entire working day in your cycling gear. So obviously when that involves lycra, eyebrows get raised.
Inspiring.
He's a perfectionist.
The other thing, I guess, that we really like about Koops is that he makes a mean margarita.
Yeah, what I like about the group of people that I work with is they work hard and they play hard. When they're here, they dedicate themselves to the task. When they're doing something else, they really know how to have a good time. I think it's very important to be who you are, and I just do things the way I like to do them. Sometimes that's extremely eccentric. Often I break the rules, I just go my own way. But I think to be successful, you have to push the boat out. Be what you are, follow your dreams, do things as you would do them.
The GSK award is about research excellence, so when I stood back and thought, what is the right person to nominate, you have to ask what are the really key questions that have been answered in biology, and working out that SRY, determined maleness, is a real biggie. And I really believe that it's time that the work that he did is heralded within the Australian research community.
Peter is one of our most accomplished scientists in molecular genetics and reproductive biology. His productivity over the years is so enormous that few of his peers could match. I think he's a very deserving candidate and awardees of this award.
It's really a feeling of relief, I think, to achieve some recognition. You know, this is a very difficult job sometimes. It involves a lot of dedication, long hours. So it's really a wonderful feeling to think that somebody out there appreciates what I do.
Well done, Koops. It's really good to hear that you've won this award. Congratulations. It's a job well done.
Koops, congratulations on winning this award. It's really great. It's great for the lab, and especially it's great for you. You deserve it.